Here we are looking at water extent, which is variable depending on the lakes that we are looking at. We know various lakes have changed over time. Also, from our background is that Digital Earth Africa is helping everybody to access this useful data for decision making. This is open data from Landsat and Sentinel, and we're looking at the various areas from various examples, thematic areas. The products that we've developed, one of them is the water observation from space, which is now has more than 30 years from 1980s to date. We have the crop mask, which is already developed now lately also for the Sound countries, and the Sentinel-2 and Landsat annual geomap, which are cloud-free. Also, just a small recap for those who've joined us is that you can access this data using the various options, the Africa map, the sandbox, and also using your API like the QGIS or ArcGIS. From the sandbox point of view, you can access these particular notebooks, especially now the new ones on the monitoring the water extent. And we have two examples, one using the water observation from space and the other one using radar, and they'll be very useful for going forward. So just giving you an overview of the new one on the WOfS, it gives you an opportunity to load the data. For example, we'll be looking at an example of a shape file or JSON file that you can actually add on your data file. I'll actually able to show you on the sandbox itself. It's just a summary view of what is covered. And looking at these WOfS, our objective is to cover the water extent. Various landscapes have changed over time. And this particular case, we had the example of Lake Baringo, which has experienced a lot of variability. And once the notebook starts, it's able to load and compare with the rainfall data, which is very useful. And also you can sample your results based on annual or quarterly. When you look at this particular notebook going further is that you can specify the time for the analysis. We are interested in time of 5 or 10 years. And the resolution is at 30 meters at the moment. And you can also change that to make it run faster from your side. Also, these are some of the preliminary results we have for this particular lake, Baringo. So we had a time where it's actually the levels were a little bit low, and towards end of the 2019, there was increased precipitation generally in some parts of Africa. And comparing this with Chirps data, we can see the same with the water body, even from journals or newspapers or even information outlets, journalists were covering flood in certain areas, and you could see around September the levels were quite high. And also we need now to compare with the rainfall data from Chirps, which is now available on the Amazon Web Service. And with this comparison, we're able to plot a comparison between the two from what we've plotted and what is available as was recorded as rainfall. And you can see declaration where there is increased rainfall is around June, September, around this region. And this was this is confirmed by the increased precipitation, especially in the year 2020, which was also similar, I think, also for Lake Chad, which I'll show you in a different example. And now we're able to set a comparison of two dates, for example, 2018 and 2021, and we're able to see some of the results. So on this is a summary, the Lake Baringo we're able to plot this over time, and you can see where areas water appeared and where water disappeared and where actually water like on the shows, it was increased precipitation, that's there were floods around these areas. Similarly, it was similar for Lake Tanganyika, a file which I was able to gather, but not so much information was there. And for Lake Chad is also similar based on what has been collected. And you can see quite some dry areas, and sometimes when there's increased precipitation, there's quite some rainfall. So I wish also to give you show you this example now on the notebook, which is here. At least it gives you a better result. So from this, I was able to take you through the particular notebook. Let me now do a new share. So this is where we have on the sandbox, once you log in, and you can still use the 32 GB, which is free for now evaluation. And in the use case, you'll see multi report extent where we have the WOfS and the Radar files. There are only 3 files, and you can always make several copies where you actually do save as a notebook using a name of your choice. So I have Lake Baringo, which I'll just take you through. What actually I mentioned in that small PowerPoint where you load the data. So the data is located in this particular folder. So this is the Lake Baringo extent, and our colleagues were able to share. This is our partners, Regional Center for Mapping, were able to share more information like the catchment area and the Lake Baringo extent, which is also quite useful when you're doing this particular analysis. And as you can see, back to the save file is that you're able to load it, specify the time range, which I was able to show you, and also the resolution at 30 because of WOfS. And this was a plot around September 2020. We had quite some peak in most lakes in the Rift Valley. I think the same was in some parts of the continent. Also, we had increased precipitation around September. And when you plot this and compare this with the rainfall data available in the Amazon Web Service, Chirps data, you can see increased rainfall around the same time in September, showing quite some floods and so on. And when you compare now the 2 dates from 2018 2021, you can see areas which were witnessed to have increased precipitation. And this was confirmed in the various newspaper articles and journals. And the good thing with this particular notebook as a summary is that it is able to export as a water change and a water and rainfall. So when I look for the Baringo, you'll see it's quite similar and so on as I showed you in the particular, as you can see from here. All this can be exported, or you can also choose to do a screenshot, but everything comes here, and you can also choose to rename it. So similar example, I was able to do the same for Lake Chad so that we can see how things are in different areas of the continent. And still the same data loaded this particular folder, and going, we could be able to see what has changed over time. And we're able to see the plot, which is quite variable. Some increase around September when some rains, then it dries towards the mid of the year, March, June. Then a peak is noticed around September going to December, then it dries. And so that's a different peak based on the area, which back from agreement, they have actually done more on the same. And you can see this also correlates with the rainfall pattern, which is peaked around that time. And now you have this image as a result, which shows you also the extent where water was noticed, and also in terms of size in kilometers squared. Very useful for decision makers. So the other challenge is also how we collect this data. So that one was through our partners. We were able to share some of this data, including the lecture file, as you can see, the extent, and the catchment area, which runs between many countries, also from Nigeria to Chad to Central African Republic. It's quite, this information is with everybody in this call, that we need to work together while you share more data on the same. So from the internet, I could gather that you can have some shapefile on the lakes, but very minimum information on the extent. So like what I could gather from these 2 files, they're only giving the extent, which was not able to plot nicely, but apparently they were giving very interesting results. So I could also go for the example of Lake Ngami as well in Botswana, Okavango, which runs for a small area, which really resonates with the recent blog we had with Dr. Kelebogi. Some dry areas were really bad, droughts and floods. And similar result is how it looks even now when you look at the Africa map. So I wish to pause for any question if you allow me to cover the radar, but it will be best if you can have some intervention from any of you. So this is where you clap or you ask a question, at least so that I can know I'm not talking to myself.
For
Yes.
the catchment, sorry, for the catchment areas, other than getting the data directly from the institutions, is there like a library that has the catchment data?
Thank you, Victoria. This is a question I was saying that this data on the catchment is not so much available. Like when you are looking for Lake Tanganyika, the various sources talk about the catchment area, but you go click and they say you need to buy like maybe a map. That's what I was looking at. And looking at yourself who's in the open data field, it's quite a challenge to get the data that you can work with and possibly use it as a catchment area. But the shapefile for the lakes, I think you're able to access. Thank you, Victoria. Anyone else? Yes, please.
Just a follow-up question. How do you access the shapefiles for the lakes?
Yes, there's a link with these shapefiles for lakes. I know with your background in hydrology, you have several sources. One of them was a source from the this ICRAF World Agroforestry Center, where they have shared a shapefile, which I could share in the chat, which has this link and some metadata information. So it means also we go back to the drawing board of where do we get the data and how is it possible to get data that can work for someone? For example, with your PhD research, I know you have access to a lot of data sets. Eileen, over to you.
We may check.
So also there are also our partners, implementing partners on this call, like RCMRD, they were able to provide information on the Lake Baringo and others. And I think through the intervention, they can do the same for Lake Tanganyika. For Lake Chad, we were able to work closely with Agreement to get this more information. So it's more of working together to see how we can work best and which data sets we can tap. Thank you so much, Eileen. Also, any intervention? Maybe just go to the next session of the presentation. So I was trying to do it in short bits so that we can have an understanding of the same. So here is a summary of what I talked about using the water observation from space. Then similarly, we can do the same using Sentinel-1 data, which is similar steps. Other than then we load the Sentinel-1 data and convert it into usable format, digital numbers. Then we calculate the water index. Then we do the resampling and plot the data over time and load the rainfall data for comparison and to try to do comparison of two catchments or two different periods. So this is again is the example of Lake Baringo using now for Sentinel, and you can see it was quite variable. And we can also compare this with the final results. So on the left, I have Sentinel-1, and the other one I have water observation from space. So one thing which was noted by most of the scientists is that the curve, the peak is quite interesting. With the Sentinel, this smooth curve based on what has been observed. And with the WOfS, there's quite some challenge in terms of very strong peaks. We can attribute this to the processing or also the reflectance properties of the two data sets. But at the end of the day, the comparison is that you're able to see where there's a peak at the right time around this particular month of September. At least there was something that can be communicated. And finally, looking at these two results is that the WOfS observation and the Sentinel, they give similar results, and they also help us address some gaps. And also the final thing that is very important for us is that we need to continue to work together to provide that ground data, which is useful for validation, working closely with the statistics offices, or also working with the citizens generated data to validate the information. So on the same, I could also pause there and go to the notebook itself. We can see. So on the notebook side, you've been able to see the file with the links, which was posted. Now in front of you, you can see the file with, this is one with the Chirps. So I'll go for the radar one for Lake Baringo, which is similar to what we discussed earlier on. And this notebook is very interesting that you just need to have the exact data sets, the water extent, the catchment, which were loaded similarly, and load in your data, convert it to the digital numbers, and the water index has been converted. And you can see the curve is similar to what just presented as a summary. And the final output is here. Then looking at the same for Lake Chad is also possible for any big size lake. We can do it based on the availability of the data. Then finally, I wanted to show the summary of in the original file, this PowerPoint here, that the results were looking like was similar. Just one before we pause is that I need to show you the GitHub file, which describes the more information on the same. As I wait for any intervention, I was making it very simple for us to follow up. So all the amazing work done by the team is posted here, like in the GitHub, which also is a summary of the data, the same which I've shown you, but now on GitHub, where you can actually see the steps, and also you can see the same file, which you can actually just share with someone instead of logging on the sandbox, just to show a summary of what can be done or what is possible. So these possibilities are also useful in case you're doing your own training or you're working with different partners in different sectors, and you really need to show them the notebooks available in the Digital Earth Africa. For example, you can see other folders and other notebooks that are useful. So in the case of today, we are looking at the use cases, and we are looking at the monitoring water extent. So I wish to pause for any question. I know it was a short presentation. So Fatu was asking about this error. Sometimes it happens when you are running the radar notebook and not the water observation from space. Fatu? Buju, Fatu? Yes, so you had a problem with one of the notebooks.
Yes, this notebook that you are running. So there are not one alert to pocket is not working.
Yes, so most likely this is coming from a refresh, or when were you able to access this?
I did it yesterday. I did it today. And I have the same.
Was it for the radar or for the?
For the WOfS and for the radar.
Okay. So it's just a small refresh because I think Eileen had the same error. Eileen Magero.
Yes.
Okay.
And did it work again?
Yeah, it worked. I ran the notebook you sent.
Okay.
And it was.
Yeah. Okay. So Fatu, when was the last time you checked? Because every time you log in into your sandbox, it will show you the files again, and then you can try like the default values, the default notebooks. Like these ones, I opened them 2 hours ago. So every time I sign and log in, it gives a refresh from what is available.
Okay, I'm gonna try again.
And also, you've also been added in the WhatsApp group. You can also, are you able to share a screenshot or so that we're able to see where the error is?
Okay.
Thank you so much.
Thank you.
So any question or comment? I've shared the PPT in the chat for follow-ups and also understanding. And also if you're able to replay the same on your side. For example, you need to maybe do another example for an area of your choice. You're working with different partners, different persons, or they have asked you information about a lake which does not exist. Not sure about which lake you're looking at. So maybe I can share my QGIS just to give you some other part of it. Is that from the data which I shared, it's possible for you to view it on your QGIS. So this was just some data that I was trying to add. So you can zoom into the layer. You can show layers. Yeah, it's activated. So this was an example for one I was looking for the lakes now in Africa, and I was looking in the south part of it. And the beauty of it is that you can go back to the principles of the DE Africa and add a layer from the WMS as a base file, which can be useful like the GeoMart. So I was able to load one for the southern countries to navigate where a certain lake was. I was looking for Lake Ngami in this case. So this shapefile I've given you, I know it's very big for the whole continent, and you just have to navigate through, or you can even add it on your Google Earth as a KML. So looking at the big lakes, they load very well, like Malawi, Tanganyika, which I just showed you recently. We can also go to the West Africa part of it. So this shapefile is quite useful. It's from the World Agroforestry. So like shadows of loads. So they actually load in the very good data, and in the background, the GeoMart is loading from Sentinel-2 in your QGIS. So it depends, any platform that you work with, you can still access using your QGIS or ArcGIS Pro, etc. Then you can export the file as a shapefile or a GeoSem, and then you can copy it into that folder. Just drag and drop. I can see someone's hand is up. That must be Edward.
Yeah, elegance. Yeah. Just also wanted to for the question that Fatu Sane also asked. So can you share your notebook with us so that I can also give a simple explanation on the water extent?
Yes, Edward. I'm sharing shortly.
Okay.
This is the water observation from space.
Yes, thank you very much, Ken. So if you look at the file directory, you notice that there's another Python file called long-term water _extent.python. So if you have created another folder and you've copied the notebooks into that folder, that means you also have to copy the long_term_water extent to that particular folder also. So if you copy any of the monitoring water extent notebooks and you don't copy the long-term water extent notebook into that particular folder, you are going to get an error saying that modulo does not exist. So that's what I also wanted to add to it.
Thank you very much, Edward. And this also is also available on the same folder on the GitHub as well. So they go together where they are copied to.
Okay, so I need to copy the long-term water extent also.
So any question? The presentation is shared here. I also welcome in Stella Mutai from WFP and Deborah. And I know Fatu is calling from CSC, Senegal.
Yeah, I have one question.
Yes, Bako.
Thank you, Ken. Thank you, Edward. I think this script is very, very relevant for us according to cloud coverage and so on. So you know, to identify the water presence. And sometimes we are using Snap, the software that you all know. Snap, but my question, I saw that with Snap, it's taking time to get the result and to make the conversion between the SAR data and the topographic and the coordinates that we have is very, very difficult to get all those things. But my question, I want to know in which component those aspects of processing are taken in consideration. Is it in where we have a connect to data cube that we have all those steps, or I can see them exactly in the script? Thank you.
Thank you so much, Bako, for your question. And I know the pains and points of working with Snap. So just as a small summary is that everything in the D Africa is already in analysis ready format date, which means it has already been processed by our colleagues and partners. And our work here is to actually just access the big archive of Sentinel-1 for the whole continent, clip into an area of interest, and everything has been corrected radiometrically, and the measurements are already there. And the conversion has already been done on the fly. And these scripts make your work a little bit easier. And also the water index has been calculated for you. And it's just going to give you the results I think in less than 1 minute. Edward, do you wish to share any information? So as Edward responds, you can do the same on the D Africa maps where you can see where the radar data is. I can do normal backscatter for Sentinel-1, and you can see we already have it in analysis ready format. So we can just go for an area of choice or even the whole continent and see where it is. And also I need to change the dates because, as you know, it's done every weekly or after 2 weeks. So I need to identify the areas which have been captured. So also it depends also on your internet connectivity. So I can just go for this particular example around Malawi. I have some connection issues, but it's gonna work. So everything here, like on the south of Lake Malawi, is preloaded for the Sentinel-1 data, and ours is just to change the various bands and indices. And this is what we are connecting to in the sandbox based on the Explorer data that we have. So once again, Bako, the value of analysis ready data format is very useful based on the report from the Committee of Earth Observation satellites that making our life a little bit easier instead of downloading and going to the Snap, which might take you a lot of memory. I remember the last time we worked with you, we had problems in the computer's memory, and we had to work with disks of almost 2 terabytes from this computer to this one. Now everything now we have in D Africa is analysis ready format. It's just a format to click and go to the analysis and make our work easier. I think, Bako, this makes life easier for the year 2022.
Yeah, thank you, Ken.